So I hope everyone has joined. So good evening to one and all. A warm welcome to all the
First, ensure
participants.
that speaker is joined or not.
Sure, sir, sure.
Otherwise, wait for few minutes because one or two members only joined so far.
Sir, speaker has joined, sir, but waiting for his confirmation. Somshekar, sir, start the session, sir.
Sure, sir. So good evening to one and all. A warm welcome to all the participants and Head of the Department of Civil Engineering, Ramchandra College of Engineering, Dr. Sundar Kumar, sir. So today is day 4 Atal FDP, which is hosted by Ramchandra College of Engineering. So let us invite the today's speaker. So a warm welcome to Professor Darshan J. Mehta, sir. So good evening to everyone. It gives me immense pleasure to introduce our esteemed resource person, Professor Darshan J. Mehta, whose exceptional academic and professional achievements make them a highly respected figure in their field. Professor Darshan J. Mehta had received PhD from SVNIT, over 15 years of experience in academia. Presently, he is working as professor in Dr. S. and S.S. Gandhi Government Engineering College, Surat. SAR has published 21 research papers in SCI and Scopus. He successfully guided 30 projects at level of undergraduate and postgraduate. He have a proud member of ISTE, IE, ISH, ASCE, IAHR, IWRS. Dr. Darshan Mehta actively participated in 37 national and 43 international conferences, and he has organized 16 development programs and 5 workshops to enhance the knowledge and skills of academia and industry professionals, and played a pivotal role in organizing 4 national and international conferences. And he has delivered 30 plus expert lectures in prestigious forums, sharing valuable insights. SAR got Best Paper Award in 2015 and 2021. Got the National Eminent Academic Leader Award in 2020. He has got the Best Pedagogical Award from Gujarat Technical University. Actively serves as a reviewer for over 30 reputed national and international journals. We are truly privileged to have such a distinguished personality with us today. Please join me in welcome Professor Dr. Darshan J. Mehta to share their knowledge and expertise with us. So, I take the privilege to invite the sir to take up the session. Thank you, sir.
Hello, hello. Am I audible?
Yes, sir.
Okay.
Yes, sir. You are audible.
Yes, sir.
Audible, sir.
Okay. Thank you for my detailed introduction, and thank you for inviting me for delivering the session in the 1 week Atal Faculty Development Program. I'm sharing my screen. Just confirm me.
It's visible, sir.
Okay. Thank you. Hope my screen is now visible to everyone.
Good, sir.
Okay, so uh, today I'm going to talk on the topic use of hydrodynamic modeling for mitigating the floods. Now, it will be one case study which I'm going to discuss among all of you. So our session is divided into three parts. Number one, that is the hydrodynamic model. What is hydrodynamic model and how it can works. Second, by considering the hydrodynamic model, how to mitigate the floods. That is the second part. And by including both of them, that is hydrodynamic modeling and mitigating the flood, I am going to show you one case study of my particular region, that is a Surat city. As Surat city having faced so many times flood, and there is one Tapi river due to which the Surat city peoples are facing the flood situations. So basically, what do you mean by hydrodynamic model and how the floods can be mitigated, that we will discuss, and then we will proceed towards the case studies. Now, the hydrodynamic modeling, see, the topic is disaster, right? So flood is also one kind of natural disaster which we cannot predict properly as and when we have the rainfall data or the flood data or discharge data. It's quite difficult to predict, it's quite difficult to forecast, it's quite difficult to manage. But nowadays we have many uh, models, numerical model, conceptual model, hydrodynamic model, hydraulic model, due to which we can plan a mitigation, we can reduce the flood, we can minimize the flood in and around the surrounding regions. So basically, we will start with the basic hydrology, that what exactly, because at the end whatever we are discussing today, that is nothing but it is the hydrology. So hydrology, it means the science of water. Hydro means the water and logy means the science. And we can see that it deals with the occurrence, circulation, and the distribution. Say for example, if whenever there is a heavy rainfall, what we people or the what the dam authority people are doing, they are storing the water in the reservoir or the dam, and as and when required accordingly, they are going to release the water if the storage of the dam or the reservoir is full. Now, how this can happen if there is a huge rainfall in and around the region? Because see, rainfall is occurred on the upstream side, downstream side, catchment, and the areas which are nearer to the catchment. So this all water is going to store in the dam or the reservoir, due to which when there is a heavy rainfall, we need to release the water to protect the city, to protect the dam, to protect the area which is located near the catchment. So we need to tackle such type of situation. Now whatever the case study which I am going to discuss in front of you all, it is the same similar case study in which the dam authority people have stored the maximum amount of water, and when they come to know that this is a critical situation, they have released the water of more amount of discharge at a same time period, and due to which the city faced the flood situation. Okay, now the role of the hydrologist, we all people are aware, that is the assessment, water use, water control, and pollution control. Now these are the various hydrological application. Now see, why these things happen. As we all know today, there is a vast impact of climate change all over the world. Right? You people might be agree with me that nowadays we won't be able to see the climatic condition. We won't be able to predict the climatic condition, right? Because see, our basic season of rainfall is June to September. Even though you can observe the rainfall, you have noticed the rainfall in the month of October and November also. So this is basically due to the climate change impact. Climate change impact affects each and everything like agriculture lands, irrigation scheme, drainage system, water sewerage system. So everything is affected by the climate change. You have also observed that you are living in one city. In that cities, in some part there is a rainfall, and in some another part there is no rainfall. So this is also due to the climate change. So we can say that it is an uneven rainfall, or you can say unseasonal rainfall like that. Now, what is a hydrological cycle? This is a very basic things. I'm not going to discuss in detail with this. So we all people are aware that transpiration, evaporation, infiltration, condensation, runoff, precipitation, and subsurface flow. Now, what is hydrologic system? Now, see long-term monitoring of hydrological system. Now, the long-term system we can say. See, the word is long-term. If anybody want to analyze the system, or if anybody want to predict the system, or if anybody want to uh, forecast the system, then they must have the long term data. Long term data means up to 100 years, 50 years, 120 years, 150 years, like that. Because long term data gives you the accuracy of your result outcome. Now say for example, I wrote first is the precipitation. If you have precipitation data of 120 years, you can easily check the rainfall trend, which helps to quantify the drought years as well as the flood years. Because as we all know that if the period is dry period, then it can be considered as a drought. Now if we consider as the wet years, then we can consider as the flood, right? Second, you can see it is a stream flow. Stream flow is nothing but it is called as a discharge. Now see, discharge can be have daily discharge data, monthly discharge data, peak discharge data. Now if you want, I will show you the which type of data is useful for mitigating the flood or the analyzing the flood. Now see, daily discharge data means minute in hydrograph we are aware that the hydrograph will be of 3 hour hydrograph, 6 hour hydrograph, 9 hour hydrograph, but it is not, but that is nothing but it is a discharge data, right? Then monthly discharge data, then hourly discharge data, and the peak discharge data. Peak discharge means, say for example, today is the 19th of December. If the water is released from the dam, say for example 1 lakh, again 1 hour 1 lakh, 2 lakh, 3 lakh, 4 lakh. Now, at the point and at the time when the flood situation is arising, right, on that particular time duration, whatever the amount of discharge is there, that will be the highest. So, that highest discharge will be considered as the peak discharge, due to which the flood is occurred. So, according to the study of hydrology, river is defined as the natural stream flow in a channel. The new stream reaches should be dynamically stable and should have the geomorphic properties that are the characteristics. Now, what do you mean by geometric properties and dynamical? See, your river reach should be dynamically stable. Stable means it should fulfill the properties for the discharge, depth, velocity, area, everything. And geomorphic property means we must focus on the soil, geological condition, everything we need to focus. Now, what are the data required for the hydrological studies? As I told you that we need rainfall data, discharge data, stream flow data, then data regarding the various methods, geomorphic data. Geomorphic data means soil data, geological condition data, or everything you need to be collect, right? Now, what is flood? Flood, we all people are aware, flood is nothing but it is a temporary inundation of the large region, or you can say high stage of river from upstream to the downstream, or you can say an excess of water or the mud on the land that is normally dry. Now, how the flood can be occurred? That is there are many causes: blocking of the river channel, landslides, strong tides, storms in the sea, cyclones, tsunamis over the water bodies, and wrong design of the dam or the canal. 75% of the total rainfall is concentrated over the short southwest monsoon season of the period of 3 to 4 months from June to September. Now you can see the last point shows that most devastating flood in recent time have been in 2017 Dhanera, 2015 Chennai, 2013 Assam, 2013 Uttarakhand, 2012 Brahmaputra, and 2006 that is the Surat flood. Now this Surat flood, I will going to consider the case study for this particular flood. So you will able to get the idea that how the Surat people faces the flood situation. So the flood can be defined as a relatively high water flow that overtops the natural and artificial bank in any portion of the river or a stream. Now you can see natural. Natural means the retaining wall, or you can see the levees, you can see the embankment. These is all are the natural embankment. Artificial means if you are going to construct a wall in either side of the river, then you can say it is an artificial bank. And when the bank is overtop, the water spreads over the floodplain. Now you can see the images. Now this is first image. This is the dam. When they have opened all the gates, the water is flowing in this type of situation. This is the second photograph. You can see when the water enters into the city. This is the third photograph in which you can see the water is nearer to the level of the bridge. And this is the fourth photograph. You can see the water is inundated, means the Swaminarayan temple. There is one temple which is located to the study area, and in that this is one temple in which the water is spreaded in that region, and the whole Swaminarayan temple is under flooding. You can see, and the flood date is the 8th August 2006. Right. So you can see where whenever we are going to, means the dam authority or any hydraulic engineer, which is on the site, they must aware when to release the flood water, or means when to release the discharge. If they are not going to release the discharge as a certain time condition, then there might be have the condition of the flood, and this will be hazardous to the city or the society. Now we all, as I told, there are many computer technology in the research in the numerical techniques. Various 1D, 2D hydrodynamic model based on the hydraulic routing have been developed in the past for flood forecasting and the inundation mapping. Now see, hydrodynamic model is also having the two part. One is the hydrology and another is the dynamic. Means whatever the things which are related to the water is dynamically applied on the field, or you can say applied due to the use of the technology, but it is purely based on the hydraulic routing. Now you all are aware that there are two type of routing. One is the hydraulic routing and second is the hydrologic routing. Hydraulic routing, you can see in that can be solved with the use of Saint Venant equation, whereas the hydrologic routing can be solved or can be developed with the use of Saint Venant and as well as the continuity equation. So it is the combination of the two equations. With the use of these two equations, one can easily develop the models, and that model can be used for forecasting the flood as well as the inundation mapping. Now, whatever the study which we are going to do, that is should be applied, and it is focusing to predict the flood levels, to predict the flood levels in a small river reach for flood forecasting and protecting the measure in and around the region. And this whatever the data which we are going to collect, it can be used, it can be helped to prepare and plan for the extreme event by identifying the where the risks are highest. Now see, it is not compulsory that if there are four regions or the four zone, and in each and every zone the situation will be same. In some of the area the situation is very critical, in some of the area the situation is moderately critical, in some of the area the situation is critical, highly critical. So what we need to do, we need to prepare a plan for the extreme event, and we need to categorize the area as per the extremity of the flood. so that we can easily get the idea that which area having the risks with the highest zone. Okay, now type of flood: rivering flooding, flash flooding, then dam failure, then the storm surge. Right now, what causes the flood? As I already told you, that river overflow, strong winds in the coastal area, dam breaking. Right now, see, river overflow. Whatever we have discussed till, that is totally related to the river flow. Strong winds in coastal air means tidal. Whenever there is a tidal in the lake, in the river, then such type of situation may occur. And last is the dam breaking, when there is a heavy storage of the water and when we are going to release the water at the same time, then the dam breaking situation maybe arises. Okay, now what affects the flood? Economy, environment, people. Now, if the city faces the flood, then the roads are blocked, bridges are blocked, right? The houses are destroyed, automobiles are destroyed, people become homeless. Because see, if the flood may occur and if there is a water up to one floor or two floor or three floor, the people were not able to go for any social or any work, because the roads are blocked, bridges are blocked, buildings are also under the water, so this everything will get destroyed. Environment, it is also affected to the environment, as when the flood happen, the chemical and hazardous substances end up in the water and eventually it contaminate the water bodies that the flood end up. And many people are killed in the flash flood, many more are injured, and other made homeless because there is no water supply, there is no electricity. These everything are disrupted and people struggle and suffer as a result. Now, what is the benefit of the flood? See, as such, there is no benefit, but something, if there is a more water, then the soil fertility, whatever the damages happens, it will be washed out. You can see soil fertility. In excess of water can be damaging to any natural or the man-made structure, but the replenishment of essential nutrients in soil is possible with the flood water. Sometimes we can say that if there is a flood in the area where there is no water, there should be benefit, because their agriculture production will be increased, their irrigation of a crop will get increased. So this thing should be considered as the benefit of the flood. Hydroelectricity, if there is a huge amount of water is stored in the dam, right, and due to the turbine, the electricity is going to convert on the dam side, right. And last is the financial input, then awareness, people will get awareness. Now, disadvantage, it can cause damage to the property and the home, it can cause loss of life, it can kill animals, it can cause damage to the vehicles. Now, these are all the flood preventions which we have already discussed. So we can say, for preventing the flood, the most important, that is to build a structure of a dam. The dam structure will prevent the flood in a proper manner. Now we will switch over to the case study which I am going to show you. Now see, what is the study objective? We are going to use one software, that is a HCRUS. HCRUS is Hydrologic Engineering Center River Analysis System. It is developed by the US Army Corporation of Engineers. And with the use of this software, we will use the we will compute the different cross section of the Tapi River. Now, I think there is some disturbance.
I request all the participants to mute yourself.
Okay. So,
Kept mute, sir.
okay. So, whatever the river reach which we are going to discuss with you today, that is about the 11 kilometer, and that will be between the Sardar Bridge to Magdalla Bridge, right? So, this river reach will going to analyzed for checking the adequacy of the river using the past flood data or the discharges. Then we also going to determine the adequacy of the existing section to carry the flood of various magnitude. Then to recommend the measure to assure the safe flood conveyance for the study region. So four objectives are clearly defined. Number one, to compute the cross section. I will show you that what is the cross section, what is the software, how the it can be worked for adequacy of the existing section. Now this is the study area. I will show you. This is the total 7 zones are there from the flood cell Surat. See, this is the river Tapi of the Surat city, Gujarat. Uh, Now, most important thing is my study area is between the two bridges. That is the Sardar and Magdala bridges. Okay, so I will show that how the cross sections can be divided. Now, what type of data is needed for analyzing the flood situation or mitigating the flood? So see, field data were collected from the hydraulic department. Now, what is field data? Field data means the cross-sectional data, longitudinal sectional data, right? Now, field data, it means that if you have means if you are going to visit any corporation office or any hydraulic department, if they don't have the cross-sectional data, then you can also do the same type of field survey and you will get the field data. What type of survey you have to perform? You have to take one theodolite, you have to take staff, and you can take the readings as you people are doing the practical for the surveying. In surveying, we people are drawing the contour sheet by considering the number of readings on the hilly area site, right? The similar kind of survey can be done on the river basin, and accordingly you will get the field data. Now in this study area, the reach is of 11 kilometer and total we have 49 cross section which is to be analyzed, right? Detail and what will be the interval between the one cross section and two cross section, that is the 200 to 250, right? I will show you the photo also. See, this is the study area. This is from the Sardar Bridge and this is the Magdala Bridge. Now this red line indicates the cross section, right? So I told you 49 cross sections. So these lines shows the 49 cross sections. And another thing which I show you that the interval between the one cross section to another is 200 to 250. It means that this is one, this is 1, and this is 2. So the distance between both of them is 200 to 250. Okay, I hope it is understood that for this is the one cross section, this is the two cross section. The distance between first one and second one is 200 to 250, right? And the whole river reach starting from this to this, right? The distance is 11 kilometer, and 11 kilometer is divided with the 49 cross sections, right? And the starting point is the Sardar Bridge and ending point is the Magdala Bridge. Now another thing which I am going to focus with you is that there is a natural wall, right? This is a natural wall on left hand side and this is a natural wall on right hand side, right? Left hand side here, this is the left hand side and this is the right hand side. Okay, so now you have a natural wall RL also, that is a reduced level, right? So what you need to do, you have to consider that RL while performing the analysis, right? So if your area is under flooding, means water is going to overtop in your particular section, what you need to do, whatever the natural wall is existed, you need to increase the height of the wall, or if there is no wall, means does not exist, then you need to construct a new wall. So there are many structural and non-structural measures related to the flood, relating to minimizing the flood. That is the flood warning system, flood zoning system, then construction of the embankment, construction of the retaining wall, construction of the levees. So such type of thing you can consider as a structural measures. Okay, So detailed longitudinal section, past flood data from the research paper on the flood cell of the Surat city, detail of the storm water drains and outlet are collected, and top RL of left side bank and right side bank of the study area are collected. I told you that RL is also needed if there is a existence of a wall. Right? If there is no wall, then it is okay. Then you can consider as the natural wall. Now, what methodology should be adopted? Number one, that is the hydraulic modeling. Number two, uniform flow computation, and last, that is the comparing the existing section with the component section. Now, see what is hydraulic modeling. Hydraulic modeling is working for the software that is a HECRAS. HECRAS is Hydrologic Engineering Center River Analysis System, which is developed by US Army Corporation of Engineers. It is freely available. It is open source software. One can easily download the software from the website of the HECRAS. And maybe the latest version is the 6.1 or 6.2. I am not exactly aware, but you can check the website. You will get the latest version of the hacker software. And another thing, one can easily check one can also use the software for water quality. One can also use the software for sediment transport capacity estimation. And as I said, we can also do the performing the analysis for the flood modeling, flood prediction, flood forecasting, flood management. Everything you can do with using this freely available softwares. Now, hydraulic modeling, this is the user interface of the software. US Army Corporation of Engineer, Hydrologic Engineering Center, River Analysis System. This is the full form of the HECRAS, right? And right now you can see on my screen the version is 4.0. The latest version is 6.4 or 6.2. Exactly, I'm not aware, and it is freely available. Now, I'm not going to go into the detailed history of this. You can check on the website. We can directly switch over to the case study. Now, these are the tools which you can see in the hackers. These are the new features which are added in the newly version. Now, see, I told you before starting our session that hydraulic routing and hydrologic routing, certain equations are there which use and which analyze the system, right? In each and every software, they have installed the system equations, right? So similarly in hackers also, the cent moment equation and the continuity equation they have added, and with the use of that the analysis is to be performed. So now hydraulic analysis, in this you can see the standard step method is used. Standard step method is used, and in which the energy equation they have used, right? So what is energy equation? You can see on the screen y2. Now why 2 and 1 is mentioned? Because there is a inlet and there is a outlet. So cross section having the inflow, that is considered as an inlet, that is, and at the end when the water is going to go, means water is going to release from the end, that is the outlet, or you can say the outflow. So if anybody wants that what will be the total storage of your river, then you have the formula that delta S is equals to inflow minus outflow. What is delta S? Delta S is nothing but it is the storage, or you can say it is a change in storage. You will get the output that what will be the storage of your river, right? Now, in any river there are certain losses like seepage loss, evaporation loss, energy head loss. Now if you are performing a steady flow analysis, steady flow means your discharge remains constant, right? Say steady means the discharge Q is constant, right? If your Q is constant, then there is no loss. But if your Q is changing as per the time, then there will be the loss, right? So see, when the constant discharge, no loss. But when it varies with the time, then there is a loss. Loss may be of energy head loss, right? Because how the energy head loss will be occur, it is due to the friction, And due to the friction, there will be the contraction of the river ridge, there will be the expansion of the river ridge. This may happen, right? This is the continuity equation. Q is equals to A1 V1. You all people are aware. This is the energy equation. This is the flow resistance equation. Now we go to the analytical part. Now see, this is the user interface of the software. When we are going to open the software, you can see such type of screen, right? Then after going to this screen, you need to open a project and save the project. These are the program structure which is mentioned in the software. This is the channel geometry, this is the flow boundary condition, this is a scour. Yes, another thing, you can also do the analysis for the scour, that how much scour is there on the bridge if the bridge is constructed near the river, right? And what type of outcome you are going to get. You will get the cross sectional profile, you will get the rating curves, you will get the 3D cross section, and you will also get the tabular data, means a result in the result form. Okay, now this is the open a new project. Then after unit, see, the software is developed by US Army Corporation of Engineers, so they have given the option US customary and the SI. So we need to select the SI unit, because we have all kind of data either in the meter, either in the centimeter, time will be in the second or the minute. Now the most important data which you have to use for performing the analysis is the geometric data. Right, now what do you mean by geometric data? I already told you that if you are with the staff and the theodolite, you will have the readings like a contour, right? So that readings will be considered as a geometric data which can help you for developing the geometry of your river ridge, right? As I said, there are 49 cross sections in the Tapi river ridge, so each and every section has its own geometry. I will show you one example of the geometry. Now once you enter into that window, the computer will going to ask to create a new river ridge. Okay, so you need to select this option. By drawing this option, computer will allow to draw the ridge like this. Okay, or like this. If there is a tributaries, then you can also draw the tributaries in the river. Like see, I show you one example that this way one can easily draw the river ridge. Then this is the data sheet. See, this is the station number which is in meter, and this is the elevation, that is also called as a RL, reduced level. So I stand at 0 position, the elevation is this. Then 10-meter distance, again I stand at the 10 point station, I will get this. So after getting all kind of readings, see, 0 is the first point of cross section and 830 is the last cross section, right? So see, this is your river and this is your cross sectional. Okay, so 0 is at this point and 830 is at this point. So this way 0 to 830 readings will be taken. Once you complete it, take a distance of 200 to 250, another cross section, enter the data. So these data to be entered into the software, so software will draw this type of cross section of the data which you have entered. So this is the data for the cross section number 1 data, that which I show you, this one. This sheet is for the cross section 1. So you can see these things will be drawn by the software, and in the original also you will get same type of thing. Okay, now see, I have entered the data. See, this is the window cross sectional data. Now from where you have to enter, that I will show you. See, this is the window. In this is the option cross section. So once you select it, you have to enter this. See, when you have drawn this river ridge, computer will get automatically idea that this is the river and this is the ridge. You can see this one and this one. Okay, second thing, computer will also get the idea that you are going to enter the cross section entry of river station number 1. Okay, so you can see this is the station, this is the elevation. Station is in is a number, and elevation it will be in the meter. Okay. Now you can see on the right hand side of the window, there are certain things. Number one is the downstream reach length. This. Focus on this window, downstream reach length. Okay. Now in that there are three options. LOB, that is the leftover bank. Channel means if you see the water, that is a channel, and ROB is the right hand side. Okay. Now I will show you the LOB and ROB in the study area, so you will get the idea. Yes. See, this is a LOB, this is a ROB, and whatever the water which is there in the river, this is called as a channel. Okay. Right. So this way. So now what you need to write here, that is a distance between first cross section to another. Okay. So here this is a first. So there is no any distance. So you have to write 0, 0, 0. Now, when you are going to enter the second cross section, you need to enter 250, 250, 250 because the interval between the one cross section to another is 250. Okay. So in the first, you need to write 0, 0, and 0. Now, Manning's value. Yes, Manning's n value is also important while performing the analysis because the value n is depend upon the bad material level. Okay. So the bed level may be vary from cross section to cross section. So you need to check what kind of bed material it is and whether your bed material is properly uh, existed or not, right? Because Manning's n value is based on the bed material, which type of bed, whether it is a coarse, whether it is a gravel, whether it is a sand, whether it is a clay. Based on that, the n value can be defined. Right. So n value maybe for the Tapi river, the n value is calibrated by SB90 Surat professors, and the value will be 0.025. Means they have given the range from 0.02 to 0.025. So we can use any of the value between this range, which can help us to analyze for the flood modeling. Then mean channel bank station. It shows that when your left bank is started and when your right bank is started. So you can see the first reading is 0. You can see. Yes, your first reading is 0. So it is the left bank and 830 on the right bank. Means my cross section started at 0 and ended at 830. So that you have to enter in this. And in the last point, that is the contraction expansion coefficient. See, this will remain constant for the steady flow. Now, what do you mean by steady flow? Steady flow is that type of flow in which the discharge Q remains constant with respect to time. So right now, whatever we are discussing, it is purely based for the steady flow analysis. Okay, so steady flow analysis in which the discharge will remain constant. Okay, so hope everybody understood this particular slide which I have explained each and every factor. If anybody has any kind of doubt, then please ask me for this slide. So I hope everybody understood by the everything for this slide.
Sir, could you explain again, please?
Okay, fine. Okay, so again I am going to repeat it. See, this is the cross-sectional data window in which you can see the river station, reach, everything is mentioned. Okay, now when it will be on the screen once you draw the river reach. Now see, uh, if you draw this, computer will automatically, means software will automatically come to know that you have the river name Sardar and reach name Magdalla. Okay, and when you are going to enter the first cross section data, so the computer will give you river station number 1. When you are going to second, then 2, 3, 4, 5, then so on. Okay, now you can see the window, station and elevation. In my previous slide I show you the data sheet for the cross section. This is about the station, this is about the elevation. So station 0, 10, 20, right, which is in meter, and this is the elevation, that is the RL, reduced level, that is also in the meter. On the right hand side, that is the downstream reach length. It will be the distance between one cross section to another, but right now we are talking about the first cross section, so it will be 0, 0, 0. Then Manning's n value is purely depend upon the type of the bed material. So for the Tapi River, the Manning's n value is calibrated and validated by the NIT Surat professors, and that is ranging from 0.02 to 0.025. Then next is the main channel bank station. It says that when your means at which point your cross section started and at which point the cross section is completed. And the last point is contraction and expansion. As we are performing the steady flow analysis, so there is no any losses. So we don't need to change in this contraction expansion point. Okay, now I think one of the participant has raised the hand, that is the Kaushal Ram. Yes, if you have any question, then let me know. Kaushal Ram. Okay, fine, we will continue further. Now see, I told you we have added cross section number 1. Now if you want to add another cross section, go to the option window, right, and you have the option of add a new cross section, copy cross section, or rename reverse station. So you need to select the add a new cross section. Once you click on that, again you will have the window like this, and you can complete it. Means then you have to add it. Okay, so the same process can be performed for all the 49 cross sections. Now we go to the run analysis, that is the hydraulic design function window. Now in this uniform flow computation, I will show you, go to the type, now steady flow. Now you can see whatever data you have entered, it will be on your screen, right? Now this thing you need to enter: number 1 slope, and number 2 discharge. The software will automatically calculate the water surface elevation. Now what kind of slope you have to enter? You need to enter the slope of bed, means bed slope. You can see this is the cross section in which the water, you can see this green color is the water, right? So you can add the slope and enter the discharge of the year which you are going to analyze. Now say for example in our study we have to analyze for the 2006 flood. Okay, so we have the discharge of 9.10 lakh cubic, but we need to enter it into the cubic. So that is 25,758 cubic. So just I have to enter into the meter cube per second. Once I entered, the software will give me the water surface elevation. That water surface elevation will be compared with the left hand side first cross section and right hand side first cross section. Means it will be compared with the point of this number 1 25, and second it will be compared with the, see, it will be compared with the first elevation, and it will be compared with the last elevation, so that you will be able to know whether your cross section is critical or not. If it is more than, if your value which you obtained is more than the existing, then you can say it is overtopping, right? Now see, I have entered the discharge of 1945, that is the 29018, right? After entering that, you need to apply and then compute, right? This is compute. Okay, so when you compute it, the software will check whether the section is sufficient or not. If no, then what particular section, retaining wall or the embankment may be constructed for minimizing the flood. So this is one type of recommended measures, okay, structural measure. Now you can see this is the river embankment which is already constructed on the side of the river bank of Tapi. See, this is the stone pitching which they have done near the area, and this is the embankment. You can see. Now see, once you compute the, it will give you the result like this. Now you can see this section is on left hand side it is okay, it is not critical, but on right hand side you can see your end section is this, and it is overtop up to this much height, right? So it is not compulsory that your cross section is overtop on both the side. In one side it is okay and in another side is not what. Now in this you can see second number, left hand side it is moderately critical. Moderately means up to mark. If you increase the release of water then it will overtop, and in this side it is safe. So the same. Now you can see this is the same photo. See, this is the 2006 flood in which the retaining wall was washed out. You can see written embankment wash out on upstream of the Singapore weir of Surrey. You can see this. You can observe it. See, it is noticed that the wall the wall was washed out during the flood of 2006. Right. So this is the wall. Okay. See, this is also the embankment wash on the Adajan area. You can see the wall was washed out during the flood. Now, after this, they have constructed the new wall, right? See, and they have also raised the height of the wall, due to which the surrounding region is now safe, right? Now, these are the critical sections. Okay, I hope you can see the effect. See the effect of the flood situation. That once you enter the discharge, the software will automatically give you that which area is critical. This is 1968 flood having the discharge of 43,000. You can observe, means you just think that how much discharge, that is a 15 lakh cubic. Okay, now this is a summary that which cross sections is highly critical, which section is moderately critical, and which section is critical. Now, how it can be defined? See, highly critical means if the water is overtop at a certain height, like 3 meter to 4 meter, or 5 meter, or 10 meter, then it can be considered as a highly critical. Moderately critical means up to 1 to 3 meter, and critical means up to some extent. I show you in one slide. 1 minute, I will again show you. See this. This is the case of critical, right? This is the case of critical, and this is the case of this is the case of moderately critical, and highly critical also I will show you. This is the highly critical. Okay, so this is the summary of the uh, cross sections, and which cross section is highly critical, which cross section is moderately critical, and which cross section is critical for the four flood event: 1968, 2006, 1944, and 1959. Now, if I think you might be have questioned that 1968 the discharge is 15 lakh, 2006 the discharge is 9 lakh, 1944 the discharge is 13 lakh, and in 1959 the discharge is 10 to 12 lakh. Even though the 2006 flood having many critical cross sections. Now, what is the reason behind that? The reason is that the development of the Surat city is not that much in the year of 1944, 1959, and 1968. It was developed after that. And secondly, the dam was constructed in 1971, right? So you can see there may be the effect after that only. That's why the more number of cross sections were critical. I will show you one another analysis, right, in which you can get the idea that how the city faced the flood. Now the Surat Municipal Corporation has carried out the work, right, for strengthening the river embankment in one area. Now you can see. Now you just see the flood scenario in the city when I'm changing the slide. Okay. Now see, if the discharge of the water is 4 lakh at that time, you can see the situation is like this. Now here the gray color is the area which is inundated by the flood. Okay, this maroon area is the river water, so don't focus on it, you just focus on the gray area. If I increase the discharge by 5 lakh from 4 to 5, now you can see the gray area. The area get increased. As the water flow increases, the area of inundation is also get increases. Now if I increase from 5 lakh to 6 lakh, you can see more area. From 6 to 7, you can see 7 to 8, you can see, and lastly 8 to 9, that is the 2006 flood discharge. You can see 85% of the Surat city is under flooding. You can see I have started from 4 lakh. Okay, if I release 4 lakh cubic discharge, this is the situation. 5 lakh, this is the situation. 6 lakh, this is the situation. 7 lakh, this is the situation. 8 lakh, this is the, and 9 lakh, which is already existed, that is in 2006. 85% of the Surat city is under flooding, right? So this is the real scenario. Previously, whatever we have discussed, that is the input, output, data, entering everything. But this is the real scenario, which you will come to know that how the situation will be worst, right? So in the year of 2006, the discharge which is released from the dam is 9.10 lakh cubic. It is almost 25,758 cubic meter cube per second. At that time, this is the situation of the city. Okay, so this is about the flood scenario in the city. So what are the findings? As I said that it is whatever the cross sections which are over top, it should be recommended that whatever the section which are overrotting the existing embankment or the retaining wall, the height of that wall should be raised. Another thing is the if the storm drain outlets are provided on the side of the bank river, then it should be if it is not provided, then it should be provided to uh, prevent the entry of the flood water. Then again, whatever the section which are found critical in the present study, it require the restoration, and whatever the encroachment is there, that should be washed out, and no new constructions will be allowed in the flood prone area, and it is strongly recommended either side of the bank of the river no encroachment is made up to 300 meters. Means no new constructions, no new any obstructions, no any structures should be constructed between these particular distance. Okay, so basically we can see all the recommendations are structural measure, but nowadays we have a digital technology, digital platform, so we have the options of the flood warning system, flood zoning system, right? So we can do such thing because nowadays we have a AI, artificial intelligence, right? Machine learning. So with the use of the artificial intelligence and the machine learning, we can prepare, we can have a programming, and we can also adopt the system to minimize or the reduce the flood. Okay, so these are the references which we have used while doing the research work. These are the books which I have used during the research work. So thank you so much for listening me. Now if you, this is my contact details, if anybody want to contact for the further work, you can contact me. This is my email address and this is my WhatsApp number. If anybody wants to do such type of similar work for your city, you can free to contact me. We can have the we can use such type of system and perform the analysis. So once again, thank you for listening me, and thank you the organizing committee for giving me the opportunity to deliver the session. Now the platform is open for the question answer sessions.
Now I request, sorry, thank you, sir. Thank you for your valuable session. Now I request Dr. K. Sundarkumar sir to speak a few words regarding this session.
Good evening, sir. Respected Dr. Mehta, sir. I profoundly thank you for accepting our invitation and joining in the 6-day Atal FDP, which is with the theme of disaster risk reduction. So you have addressed one sector or one of the important disaster, that is flooding, with a case study, and really it is enlightening, and it has shown thrown some light in the flood and its impacts, even through the climate change and all man-made impacts, as well as all the aspects of the flooding and all. We have discussed very nicely and very informative. And thank you very much, sir. And we have few questions, sir. So these floods, even though there are several models for prediction, like stochastic models, parametric model, variety models are available. Still, for a normal spell of rain in any city, it is getting flooded. Earlier, 20 years back, if you see, flood occurs only once in a year, once in 5 years, once in 2 years, like that. But nowadays, for normal spell of rain, not even severe rain, for normal spell of rain, every city is getting flooded. So, is it purely due to improper drainage system, or excess use of plastic, or can you discuss about this point, sir?
Yes, it is. There are many reasons. One of the reason is drainage system, because see, whenever there is a rainfall, before that the drainage system should be it should be in the maintenance, right? So in the drainage system also there are certain gates. If the gates are closed, then whatever the amount of water is there in the drainage, it will be come out, and due to which the low lying area facing the flood, that is not the water due to the rainfall. It is water which is existing in the drainage system, but drainage system has no proper line to go out, right? And the gates are closed, and due to which the water will come out. And this thing will not happen if the area is above the low line. The area which is in the low lying area, they face the situation of the flood.
Yes, sir. In the context of cities, sir, urban areas,
Yes.
urban flooding.
Urban flooding, it is also the same reason, but in that also there will be the storm drain outlet which is provided on the side of the river bank, right? Because at the end, say first factor is the discharge. If the discharge is not properly released from the dam, then there will be the flood. Second thing is the storm drain outlet. If the storm drain outlet is not properly installed, not properly gated or ungated, then also the flood may be arises. Third is the low lying area, and fourth is the as I said now, that release of water is most important. So fourth point is the whatever the system which is adopted, whatever the tenure is adopted, whatever the methodology is, it should be properly followed as per the regulations, rules and regulations. Then there may be the no situation. And the most important is the carrying capacity of the river. The carrying capacity of the river should be increased, so that the storage capacity of the river should be such that it can manage the situation. So these are the factors which should be considered for minimizing the flood. If the storage capacity is good, then it will be okay. And secondly, whatever the amount of water should be released, it should be in the time interval. Let's say, for example, in the morning 8 o'clock, you can release 1 lakh amount of cubic of water. In the evening 5 o'clock, you can again release 1 lakh. Then there will be no situation of the flood. Whatever the case study which I have discussed with you, that is because of the 9.10 lakh cubic at the same time, at the same point, and the same date. Due to that, the city faced flood. But if you release the water in a time interval, then there is no flood. So this is the most important, that the operation of the release of water should be also properly fulfilled.
Okay, sir. And what about the this urban expansion and the impervious nature of the soil, and means no proper way for infiltration. Do they cause any impact on the flooding, sir? Urban flooding?
No. There is no any impact of soil or geological condition. Only the thing is the bed material, what type of bed material, that is the important for selecting the value of n, Manning's n. Rest of the thing, there is no any important of the soil and geological condition.
Sir, how can you control these flash floods in urban areas, sir?
See, flash flood is it is one time,
Okay.
because there is no water and it is only and only due to the rainfall. So you need to check the rainfall trend, that which type of rainfall trend it is, how much the return period, how much is if you get all these things, then you can also develop the model for the flash flood also. But I think as per my knowledge, flash flood you no need to go for developing the model, because this is only one time. I'm giving the example of 2017 Dhanera district, the Rail River. You can search in the Google also, Rail River. It is a flash flood. Huge rainfall occurred and the flood situation arise. Now till today, there is no any problem of the flood. So it is one time. So there is no need for developing the flood. Yes, you can adopt such a system for minimizing that, right?
Yes, sir. We are living in a place called Vijayawada, Krishna district of Andhra Pradesh. Recently, there was a severe flood because of the overflowing of a river canal called Bodameru. So, which has created a lot of devastating impacts on the common man people. Entire part of the city has been submerged because of that flash flood. But now it was disappeared. But how can we avoid such things, sir?
See, if you have cross-sectional data of the river, if you have the discharge data, if you have all the data you have, then you can easily run the analysis, and you will able to get the idea that if the flood may be of this type, then we can put some recommended measures, and accordingly you can control that flood. Because see, this software can help you. If anybody call you, if I call you today that enter discharge of 3 lakh cusack, you will give me the details that which area is to be inundated, which area is critical, which area is highly critical, which area is safe. Everything you will give me in within a 5 minutes. But for that, you have a discharge data, you have a cross sectional data, right? Once you have all that type of data, you can easily develop a model, you can easily minimize the situation of the flood or reduce the situation of the flood.
Okay, sir. Sir, Dr. Haji Muhammad sir raised
Sir,
hand. Sir,
sir,
good
thank you.
evening, sir.
Thank you. Sir, what happened, this one Budamer, what they told.
Yes,
This
sir.
is basically,
Yeah.
upstream, some warnings. At least the superintendent of engineer, I really don't want to go controversial.
Yes, sir.
They should aware,
But let us speak
this
technical.
flood is going to come. So in
Yes,
that situation, sir, my question, now you can see our in Telangana, whatever encroachments, especially for Musi River or any other, they are completely removing. They have
yes,
full powers. So what my question, even in Trinidad, before independence of Trinidad, in Caroni Basin, no construction should be made available.
oh,
After Britishers, once they got independent, now everyone, especially riverside, you have been maybe Bangkok or anywhere, people, contractors build big hotels and all. That is the one effect, sir. Or any models at that time, what you can do? Tell me. This is purely town planning or any guidelines Indian government provided or no? Darshan Mehta, sir.
Sir, see, guidelines are provided for. Guidelines is not provided by the government of Gujarat. Means government. It should be provided by the corporation, right? As and when. So in our city, if I can consider for my city, Surat city, they have developed the flood warning system. That if some amount of water is released from the dam, they will start the siren. They
Yes, sir.
they will start the siren for one time, so people will
Okay.
get aware that this much amount of water is released. If it would be more, then they will do the siren for two times. And if it is
Okay.
highly critical, then there will be the long siren,
Okay.
so that the people will get aware that now they need to shift from one place to another. So this kind of system is developed, and accordingly nowadays we have the machine learning, artificial intelligence, we have the sensor based system, right? So
Okay.
as and when it touches to the wall, people will get aware, people will move from one place to another. So such type of things we can use.
Okay, sir. What about this? All you have shown, a crash. I used, 10, 15 years ago. I totally forgot. How about this one? We calculated, right? Like backwater effect, dy by dx, one minus, sorry, S0 minus SC by 1 minus Froude number square. So, what my meaning? Whenever backwater. So, how we will resolve that issue? Means you want to increase bank height, or what my meaning, full bank discharge if any suppose a river
Yes, so in that first you need to open the gates of the
flux.
storm.
Okay,
Yes, so once you open the storm drain outlet, the water will easily wash out.
okay,
And if,
okay,
and if it cannot be done, then what you
okay,
need to do, you can raise the height of the wall, side of the wall. You can
okay,
increase the
okay,
height.
we can
If
invite.
you increase
Okay,
the height, then water will not get overtop.
okay, okay, okay. Thank you very much, sir. Very nice presentation and very useful. I also recollect all my hydrology. Thank you so much.
Sir, it is very really wonderful interaction with you, sir. Haji
Yes.
Muhammad, sir. As a part,
No,
you
case studies are
today,
important, right? Whatever you
yeah,
study, that's why civil engineering, why very important so far. Once your Vijayawada got affected, then only
yes,
they remember civil engineering. Otherwise, everyone forgot.
yes,
Okay.
sir.
Uh,
Yes, sir.
you need to
But
motivate your students. You need to motivate your students. How
yes,
much? See, even great engineers, I still have book. This one, what is Satyanarayan Murthy Chella. So I brought those books. He was a retired chief engineer who wrote books.
yes, sir. Yes, sir. Yes, sir. Dr. Darshan Mehta, actually, this Professor Haji Muhammad was a speaker in the previous day, sir. But now
Okay.
he is very interesting in the things and all. He joined in the session and he asked questions on behalf of us. Very nice. Thank you very much, sir. And also, all the participants, if you have any questions, you can.
Yes, yes. Dr. Sundar Kumar sir,
Sir,
Dr. Mehta is very renowned, and I learn from him. I interacted, during
yes,
from
sir.
COVID onwards. Normally, I never touch him. So the Mehta is such a person,
Yes,
whenever FDPs and all, very very active.
yes.
Anytime you can call him, and
Yeah,
any help he will guide, and he will help your students also. Even
surely, sir.
you can conduct lectures. My suggestion for especially he's very practical, and
Yes.
he recently, you saw his research profile also. We are
Yes.
collaborators actually.
Yeah,
I'm inviting 20 days here. I'm inviting online, for my water resource engineers here in Trinidad. Thank you, sir.
surely, surely, sir.
Thank you,
Surely, yeah,
HOD sir.
surely we will follow your advice and we will definitely collaborate with Dr. Darshan sir and will look forward for interaction in future with our students and all. Participants,
Thank you.
any
Thank you,
questions?
sir.
Participants, any questions? So, coordinator, please mute the people.
Good evening, Darshan. Santosh Jagannath Rao.
Yes.
Very nice lecture, sir. Um, One thing is, you rightly mentioned, improper drainage, as far as the flash floods are concerned, improper drainage is, stormwater drainage system is one, and the other thing is probably the encroachments, unauthorized or illegal constructions in the catchment area and nalas, blockage of nalas, and all, that is nothing. And in the Vijayawada, what I read is it was built for, I think, 20,000 cusecs, and the inflow was 30,000 cusecs or so. That was the reason, probably, that I read. Thank you for the lecture, sir.
Thank you. Thank you, sir.
So once again, I would like to thank Dr. Darshan sir for enlightening us with another disaster, that is a flood and all. And thank you and all. And also, I request a coordinator to propose vote of thanks.
Thank you, sir. I think we are at the end of the session 1 of today's FTP. So with this, we are ending the first session with the vote of thanks. So thank you, sir. Thank you, Darshan Mehta, sir, for your wonderful session. You have covered from hydrology to the advanced level of all the dams that were constructed in today's life, how the inundation floods, how to prevent and how the inundation to be taken care of. All these aspects have been covered in this session. Thank you, sir. On behalf of the management of College of Ramchandra College of Engineering and Department of Civil Engineering, we are very much thankful for joining in our FTP Atal, which have been uh, taken for conducted for 6 days. Thank you, sir. Thank you very much. And we are expecting your future collaboration with our college, sir. Thank you very much.
Thank you. Definitely we can. Thank you.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you so much.
Good night, sir. Good night, sir. So all the participants,
Thank you so much.
stay back. We are going to start the second session. Virotam, sir.
Sir, second session will be hosted by Bhavani Madam, sir.
Yeah. So was the speaker, sir, joined?
Speaker join, sir.
Yeah. Go ahead. Go ahead.
Okay, sir. Thank you, sir.
Good evening. Can you hear me? I'm the scheduled speaker.
Yeah. Good evening, sir. Good evening.
Good evening. Good evening. Okay, I'll try and upload it. I've not done in Google Meet for a very long time.
Okay.
Let me see. Don't bother too much. It's very much there.
Continue, sir. Continue.
You have my slide now?
No, sir. No, sir.
No. I've sent it to somebody.
Somebody, sir.
Can you present, sir?
I think
Ganesh, I will share you now.
I have put it. I put it.
Yeah.
Okay.
Sir,
First of all, good evening, engineers. I am a management professor.
Professor Anitji, please wait for 1 second, sir, because we want to have an introduction about yourself to the audience.
Okay.
Virotam, sir, Durga Bhavan is ready.
Yes, sir. I will talk to her, sir.
Ma'am, go ahead and introduce our speaker, today's speaker.
Okay, sir. Good evening, everyone. Welcome back to the fourth day of our FDP on disaster risk reduction through sustainable infrastructure. The session topic is disaster risk financing. It is my great pleasure to introduce our esteemed resource person, Dr. Amit Banerjee, a renowned academician and a professional with an illustrious career in education, research, and industry. He has approximately 30 years of work experience with 10 years in corporate sector and 20 years in academics. Corporate sector experience was in international business in chemicals, pharmaceuticals and textiles. Academics experience in state and central government institutions. He has specialization in international business and healthcare. He has published papers in national and international journals. He thought the subject is microeconomics and macroeconomics, intellectual property as asset management, international business and trade, research methodology and business environment. Currently working as assistant professor in Department Management Studies, Maulana Azad National Institute of Technology. Dr. Amit Banerjee guided 8 PhD scholars. We are privileged to have such a distinguished personality with us today. Let us welcome Dr. Amit Banerjee to share the knowledge and experience with us. Now I request Dr. Amit sir to begin the session.
Okay. Dr. Sundar, you have my PPT?
Sir, it is with coordinator, sir. I will ask, sir. Are you unable to?
No. I have it with me, but if the coordinator can help me, doesn't matter. I'll just get it. Okay. I have 30 years experience. I'm a professor. That's fine. But all of you are engineers, and you know that without money, nothing can happen.
Yes, sir. 1 minute, sir. 1 minute, sir. That is the reason, sir. Actually, we are giving diversified angles of disaster risk reduction. So, though technical, financial, and even with social angle also we are covering. That's why.
Okay, so I will do it.
You are the right person to deal with the financial aspects, sir. We are very much thankful to you, sir.
Thank you.
Go ahead, sir. Go ahead, sir.
Pleasure is mine, sir. Now, as far as finance is concerned, we are dealing here with public finance. Okay. One is the finance of the corporates, that is the private sector. One is the finance of the companies. And the next is public finance. Now, let me tell you, I will allow 3 attempts. Which is the richest country in the world which comes to your mind? I'm seeing one name, Astha Yadav. She seems to be the first one. Just tell me, what is the richest country which you feel is there? Anybody? It's. I'll go to the lecture portion a little later. But before that, I have to attune you. Anybody? Anybody from the listeners? You might be thinking Japan, Germany, America, Korea.
Sir,
These are the countries.
sir,
Yeah.
sir, is it Dubai?
Okay, Dubai is too small. Too small. It's a city-state. When I'm talking of a country, I would rather have something at least like South Korea, Japan. Okay, these are the countries which normally come to our mind when we say these are very rich countries. Fair enough. They have a very high per capita income, all that thing. We all want to aspire to go there and work and live. Point is that you will be very surprised to know that these are some of the most financially stressed countries. Now, it must be a surprise to all of you. So, can we go back to the first slide? I'm yet to come to the first slide. Okay, just the first slide. Okay, now
go to first slide.
Now thing is that all these countries are financially stressed by Remember, nation states have only two ways of getting money. One is through taxes, the other is through debt. And you will be very, very surprised to know that the public debt, that is the debt held by the government, divided by GDP, that is called the public debt to GDP ratio of these countries, is extraordinarily high. China is 200%. Japan is, all these countries, Great Britain to America, these are in the range of 130 to 250%. That means the debt held by the government, by the sovereign, is 200 is two times the national income. Now this must be a shock to you. Ours is round about 75%. Pakistan is round about 82-83%. Okay, so that way we are reasonably safe, but then we are not a developed country. So remember, even disaster for these developed countries is actually a disaster, because these are already indebted countries. Now, a country or even an institution or an individual who already has a lot of debt can find the next round of debt financing very difficult. I hope you all agree with that. Now, just let me know, if you can raise your hands, how many of you were shocked to know that these countries have large amounts of debt? Just raise your hands in this. Just want to see that. Okay. Now, when these countries have large amount of debts, raising the next round of financing can be difficult. Okay. Raising the next round of financing can be difficult. However, they do it, and that is why these countries have very low interest rates, because the government pays very little on interest debt, government securities. Now, coming down to disaster. Disaster has to be financed. Now, one part of disaster is that first slide, financing disasters ex ante can ensure that financial needs in the events of disasters are met. Ex ante means before the event has happened. Now, no government does it. Believe me, no government does it. I've gone through so many public finance reports, World Bank, IMF, US Congress, Indian government, even Pakistan, Japan. No government does it. Very few state governments take some preparedness in terms of arranging the finance, but no government does arrange the finance, okay, from beforehand. Nobody does it. All governments are running in deficits. That is, they spend more and they earn less. So anybody who spends more than earn less has to live on the debt, and debt has to be repaid. In the case of governments, they never repay the debt. They just you can say evergreen it. They extend the life by another 10 years, and since the governments control the interest rate, so they are fine. And just to put a shocker to you, if you add all the debt in United States of the government, the corporations, the individuals, it would be around 2000% of the GDP. 20 times the GDP of the United States is the total debt of all American banks, corporates, individuals, and the government. So disaster can be very bad financially for all. So moral science says that financing disasters should be ex ante, that is before it happens. Now, ex post facto, those who are from government, they must be quite familiar with these two terms, ex ante and ex post facto. Ex post facto means after the event has occurred. So trying to arrange for finance after the disaster has happened will obviously create a financial debacle. I'll give you one example, though it is not of a disaster, but it turned out to be a disaster in terms of finance. We all are familiar with the term Olympic Games. In 1976, there was an Olympic game organized by Montreal, Canada. Now, Canada is not as smart as USA. They organized the event. It went off very well. Lot of world records, lot of new things were done. Lot of new people came. Okay. And what happened is the Montreal Municipal Corporation had a debt of 1 billion Canadian dollars. For the next 20 years, they were taxing their citizens. So this is what public finance mismanagement does. In 1980 was a curtailed Olympics. USSR was there because of the Soviet invasion, because of the Afghan invasion. America, UK, and so many America and other countries did not go. In 1984, Los Angeles organized Olympics. Now they made it a perfect marketing event. So they made a profit out of it. So look at the way, if it's a loss, the public has to suffer. So ex post facto option is simply not there. Whatever so far in the last 20 to 30 years, the governments, state governments in India and the government of India has done is they have tried to do something with post disaster relief management and all that stuff. And in some coastal states, they have managed to put up some early warning and all that stuff. But beyond that, it has not been great. Now, again, there are two approaches. One is pre-disaster, that is make the arrangements before the disaster, and the other is the post-disaster. Need for funds is immediate. Okay, as I've said, most bodies, government are running in deficit. Funding will always put strain irrespective of the development status. Believe me, it is always either they will have to raise taxes, and taxes, believe me, are already quite high. In both developed world and somebody said Dubai, in those countries they don't tax because they get a lot of indirect taxes and tax, and the government also runs very profitable bodies like oil and other such. So the government makes money. But apart from few Middle East states, most governments have huge deficit. And let me tell you, even Saudi government is also running a lot of fiscal deficits. I have written some papers in remittance. So my study shows that Saudi government is estimating the fiscal deficits to go high. That is why they are trying to diversify from oil. Okay, state has two routes of raising funds: taxes or public debt. There is no other third. Don't expect public sector undertakings to give them a lot of money, or public undertakings. Public undertakings are like our railways or electricity boards or electricity distribution companies. They don't make enough profits to be counted. They don't make enough profits to be counted. Next slide, please. Okay, now whenever disaster happens, the government seeks financial protections for primarily 4 different groups. These are the first target. Okay, national and local governments. The government needs money. Okay, then next are the homeowners and the small and medium enterprises, and the remaining are the farmers and the poorest segment of the population. So it always starts with the government. Government needs some liquidity. Okay. Government needs some liquidity to manage the whole thing. Local governments, here I am referring to both the state government and the municipal corporations, or in case of villages, the village local bodies. Homeowners, house owners, they needed to repair their houses, and the small and medium enterprises. Now what happens is, small and medium enterprises, the liquidity, the money which they have is quite low. Money, let me tell you, when we teach finance, we classify into two parts. One is the long term and the other is the short term. The long term, we normally, businesses invest in fixed assets. Okay. Assets which require depreciation. And the short term is used for. Beg your- what happened? And the short term is
Please mute
basic.
the other persons.
Dr. Sundar, what happened?
Yeah, coordinators shall address the issues where the excess noise is coming. Please mute them. Coordinator. Yeah, go ahead,
Short
sir. Go ahead, sir. Go ahead.
short term is your working capital. Working capital we say for day-to-day requirement. Now that is just meant to pay for the electricity, pay for water, pay for salaries, pay for any raw material, all these stuff. Okay, day to day. So they finance your current assets. Now what happens is whenever a disaster strikes, the short term first is the asset, what we call the asset liability misbalance, disbalance, and matching up of what happens is in that case the short term capital gets diverted towards the long term. The building has collapsed, so instead of paying the salaries they start fixing up the building. Now the person who has not been paid the salaries, he has 3 or 4 hungry mouths to feed in the house. His or her own house has perhaps been destroyed. So that creates a lot of liquidity problem for the small and medium businesses. In fact, looking into the monetary aspects of small, tiny, and micro enterprises all across the world, separate entries are made in account system to show how much money is due to them and how much money has been paid to them. I mean, this change has come in the last 10-20 years, that for small, tiny, and micro enterprise, it is there, everybody. The account books of, whether you look into the account books of Microsoft or whether you look into the account books of Tata Motors or any small industry, if it is making a financial account, profit and loss, it has to show payment pending, this much payment outstanding. They have to show. Okay, this much payment outstanding and this much payment has been made. So they have to. So this is where the small and medium enterprises have come. The question of liquidity and asset liability mismatch. Short term capital, if diverted towards meeting the long term, say the building has collapsed, that's a fixed asset, and you have to meet that. Now, since I presume most of you are civil engineers, so just to tell you, the building is a fixed asset, and fixed asset is something which I ordinarily try to define as something on which depreciation can be claimed. So buildings normally they depreciate at the rate of 3% per year for the next 20 years. Maybe some PWDs have different laws, but that's the general law I'm aware of. They are allowed a depreciation for commercial purpose. They're allowed a depreciation of 20 years at the rate of 3%, so that after 20 years, the business owner can plan another building. So fixed asset is like your car also. You get a depreciation for 5 years at the rate of 15%, and after that, you just have the residual book value. Everybody clear with the concept of fixed assets? Anybody? You can raise your hand. I'll explain further. Okay. So
Clear,
okay,
sir.
now what? Clear. Okay, good. So for what happens is this asset liability mismatch leads to bankruptcies. Okay, so in disaster, it has been observed that the small and medium enterprises have this effect, have larger share of bankruptcies. First, they are not insured. The bigger firms are reasonably insured. And second is the asset liability mismatch happens. That is, they divert their short-term funds to meet the long-term goals, and they lose the short-term assets, like they lose their employers and all these stuff. Their suppliers stop supplying them because they have not made the payment to suppliers. So this is what happens. So that is one aspect. And governments all over are very serious about small and medium enterprises because they are the new, they are the potential employment bodies. Next come homeowners. Next we discuss the homeowners. Now remember one thing, why see, in case of home, it is the largest fixed asset investment made by a household. Number two, if you look into the account books of governments, okay, when we do the GDP calculation, we find that the largest portion of investment goes into fixed assets. Say India has an investment rate of say 30% of the GDP. So out of that 90%, that is 27% of the GDP, 26% would be going towards creation of fixed assets. Now fixed assets primarily means plant, property, machinery, equipment. Okay. And therefore home or civil construction, civil or structural constructions form a large chunk of it. So homeowners therefore come into the picture. Apart from the fact that home is where people reside, it is also a large source of investment and savings. So remember, not just from unitary point of view, that is an individual point of view, from the country perspective, the macroeconomics perspective, in the GDP, the fixed assets, we call it G, gross fixed capital formation, GFCF. The gross capital formation is your investment. It is divided into two parts: gross current assets and gross fixed capital formation. GFCF is almost, in the case of India, it is 88-89%. For the last 20 years, it has remained the same. So a large portion of our investments definitely goes into buildings. Okay. So they need to be protected. Now, what happens is normally the average tenure of the mortgage is anywhere between, range is not average, but the range is anywhere between 20 to 30 years. That's a long-term investment. Okay, that's a long-term liability from the point of view of the borrower, and from the point of view of the lender, that is the bank or the housing finance or any finance corporation, that's a long-term asset. Remember, in the eyes of bank, those who take house loans, they are assets because they are paying them EMI. Okay, is this concept clear? Because normally when I give to this lecture to first term people, they have a slight confusion. How come homeowners are an asset to those who have taken mortgage? Is this clear to everybody? You can raise your hands. I'll explain. Okay, I'll assume it's clear. Okay, so what happens is, for the banks, for the financial institutions, the institutions which give loans for house building and other such property building, the homeowner or the property owner is an asset because they are repaying on a monthly basis, EMI basis. So they also would lose liquidity. Okay, they would also lose liquidity. And let me tell you one thing. Are you all, I'm sorry, but I'm treating you like a class. Most of you must be teachers. Are you aware that there was a crisis in 2008 in USA about the housing loan and subprime mortgage and everything? Are you aware of that? Anybody who's not aware? I mean, you can look into the YouTube, you can look into, there are good movies and good videos about that. So 2007 to 8, 7 to 8 and 9 to some extent, there was a huge crisis, Lehman Brothers and all that. Basically, it was all about mortgage failures. It was all about mortgage failures. And sometime in 80s also, there was a disaster because of some cyclone and flooding. Some of the banks went bankrupt because the house owners, mortgage payers could not pay back the mortgage loans. So what happens is, you see, the way the financial institutions function is that the loan is an asset. On their account books, the loan which they have given to you, say you are the homeowner, it's an asset. Now, say if they have given you a loan of 50 lakhs, okay, they have disbursed the entire 50 lakhs to you. So what they do is they expect you to repay them, and which you do it, say at the rate of say 2.5 lakhs or 3 lakhs per 5 lakhs per annum, you do it. What happens is they sell the loan to some other bank. Now, they may sell the loan, if it's of 50 lakhs, they may sell the loan at a discount of 1 or 2 lakhs. Say at 48 lakhs, they sell off the loan to some other bank. So say, for example, you have taken loan from Canara Bank of 50 lakhs and you have paid it for 2-3 years. After 2-3 years, Canara Bank will sell off that asset to say PNB, Punjab National Bank. Okay, say for 48 lakhs. And your money would be diverted from Canara Bank directly to PNB. Now, as far as Canara Bank is concerned, they have got an additional liquidity of 48 lakhs. That 48 lakhs, they lend it to somebody else. Okay. After 2-3 years, they sell that loan, that asset to say State Bank of India for 45 lakhs. So this is how the liquidity keeps on happening in the banking system. Are you clear? If you have any confusion, you just let me know, because this was the scenario what happened with long-term mortgage banks sometime in 1984, 85, around about that time. And because it was a disaster, lot of financial issues happened in USA. Are you clear with this, everybody? That banks keep on selling the loan books which you have, and they generate the liquidity to it. Now, if there is a disaster related full stop or a comma or whatever, then the everybody becomes liable to pay for it, and it becomes a big risk. Actually, you'll be very surprised to know most of these loans are also insured. So you have insurance companies which have paid insurance, which are taking premium from the bank, so that if somebody fails to pay the money, the insurance bank would pay back. Now what happens down the line, the insurance banks can go bankrupt with this. I hope you are very clear with the scenario which I'm trying to build up. A disaster can have repercussions starting from a homeowner right up to the banks and the financial and the insurance firms. Dr. Sundar, I can ask you only, are you clear about it?
Yeah, sure, sir. Sure, very clear, and we are learning so many interesting things from you, sir. Because we never know about this liquidity generation by banks by transferring the loans to other companies, selling and all. Very interesting, sir. Go ahead, sir.
Okay, no, because there was no response. As a teacher, if the class does not respond, you simply...
Definitely.
Okay.
All the participants are professors, associate professors, assistant professors, like the faculty, sir.
I know.
But still, we'll respond, sir. We'll respond. Thank you, sir. Go ahead, sir.
I know you. This is a first-time lecture for many of you as far as the world of finance. I'm trying to cut short, but this is the way. That's the only thing I can do. Anyway,
very interesting, sir. Very interesting. Go ahead.
What happens is, so banks are involved. There are brokers in between. There are insurance firms, and this is what happened when the housing loan mortgage problem happened in 2008. This is what happened. I'm sure you have heard of the Lehman Brothers issue. Apart from Lehman Brothers, the insurance firm AIG, the partner of Tata AIG, Tata AIA in India, AIG, American Insurance Group, it went bankrupt because it had given insurance for most of these mortgage owners. So all these insurance firms can also go belly up. Okay. And once the insurance firms go belly up, financing infrastructure becomes a problem, because it is these insurance firms and pension funds which give the maximum amount of money for long-term infrastructure. All your ports, bridges, all these are now financed directly or indirectly by insurance and pension funds. So now I've cleared homeowners, small and medium enterprise. The national local governments, well, there's the first one. They are the governments. They have to have money. Now farmers and the poorest segment of the population. Farmers again.
Shall I ask you a question, sir, or ask you at the end only?
No, you can ask me now.
Sir, even though the insurance companies go bankrupt and all, we need not to worry, because the regulatory authorities will take care of it.
No. What happens is, actually, we don't even come to know. Most of insurance companies have themselves passed on the insurance. They have passed on the insurance to somebody else, and most of these insurance in the world, you'll be surprised to know, are held by the reinsurance firm. In India, the biggest reinsurance firm is...
Sir, coordinator Ganesh Garu, please mute them.
Yeah, Jabin, you have a problem? You have a question?
Ganesh Garu, please mute that Vijaya, somebody is there, which is causing noise.
Okay, sir.
You should be vigilant about all the participants, because the speaker is annoyed. I mean, he stopped his speech.
Okay. No, I'm not annoyed. I can't speak that much loudly. Okay. So, Dr. Sundar.
Yeah, sir.
Can you just mute Vijaya, please?
Hello, Ganesh Garu.
Sir.
I told you to mute Vijaya.
Sir,
See,
Okay.
Taddur Vijaya is on not mute. Gautam sir?
Dr. Sundar, yeah. Now, as far as the insurance industry is concerned, say for example, National Insurance India, okay, or say United India Insurance. Now, if it has insured, say, a bridge, now what would happen is it would pass on the insurance to a reinsurance firm. In India, the reinsurance firm is GIC, General Insurance Company. Outside, the biggest are Alliance, you have that Bajaj Alliance in India, the Alliance thing. Then you have Swiss Reinsurance, Munich Reinsurance. These are the biggest financial firms of the world. Swiss Re, Munich Re, Alliance, these are some of the biggest financial institutions of the world, and they hold a lot of these insurance. Actually, the insurance of the world properties, okay, whether it is current or fixed, a lot of it is held by these reinsurance firms. Incidentally, I'm digressing a little bit, but yes, that was a disaster also. All of us are familiar with the infamous, the sad disaster of MH371, the Malaysian plane which simply disappeared. Okay. Some portion of the insurance was held by GIC of India, General Insurance Corporation. So it had a problem paying back that amounts. And at the same time, it was also holding the insurance of another Malaysian Airlines aircraft, which was shot over Russia and Ukraine in sometime in 2014, when that incident happened. So GIC was holding the insurance for both of them. Okay. So reinsurance firms actually hold almost all the, not all, but a large portion of the insurance of the world is held by these various reinsurance firms. The globally, these two, three are the famous ones: Alliance, Swiss Re, Munich Re. Okay. So these are the insurance firms, and they then pay back the money. Sometimes they also go bankrupt. Like I said, AIG went bankrupt trying to pay back all the homeowners who could not pay back the mortgage to the banks. Okay. Now, so you have farmers, poorest segment. Farmers, I need not say anything. India is an agricultural country. 44-45% of the population is directly in agriculture, and 20% is indirectly is in the ancillary units. We all know the question of their liquidity, how much or how little they have. And farming, let's admit it, as a profession, as an economic activity, what we teach in class has reached long since in India a point of diminishing marginal returns. That is, for every extra rupee invested in farming from the private, that is from individual, the monetary profits which are emerging have kept on decreasing. Until and unless there is a large public financial investment, things won't improve. So farming, yes, but unfortunately, you cannot neglect farming, because farming goes, famine happens, governments get toppled. It's a very simple thing. Food shortage, government gets toppled. That is what happened in Sri Lanka. That is what happened to some extent in Bangladesh. Food shortage, governments get toppled. So no government would like to have that kind of scenario, that the farmers are left to fend for themselves and there's a food shortage. Another thing, being an activity which is in the land, theirs is in any kind of disaster, theirs is the first one to get affected. Also affected is the transportation supply chain system, the railroad network. So all these have to be, especially the farming sector needs protection, and that is very well documented. The poorest need protection because that I'll come to little later, how they can be ameliorated. That I'll come later. Okay. Now we come down to the 4 core principles of disaster risk finance. Speed matters, but not all resources are needed at once. Okay. Speed matters, but not all resources are. Now, what happens is in the scale of timing, okay, in the scale of timing, if you plot in your x-axis time and y-axis resource requirements, the stages are: immediate money is required for relief. Then the second important part is the second urgent part is recovery, and the third is the reconstruction. So the first set of finances are required for relief measurement. Now that is a small amount. The first, go back to the previous slide, just the previous slide. And the second principle, four core principles of DRF. Speed matters, but not all resources are needed at once. Okay, so you will require resources in three stages, that we must understand: relief, recovery, reconstruction. Reconstruction is the most expensive, takes the largest, but is required at the end. The immediate is relief, and again, relief material and all that stuff, it needs liquidity. So the financing institution must have a good arrangement of working capital, what we call as the short term capital requirements. So small amount but quick, small but quick short term capital requirements are required immediately. Okay, so that takes care of the relief. Next comes recovery. Now requires, so whenever, normally what happens is, the relief is provided by specific institutions or specific organizations. They must have the required finances with them. They must have the required finances. Once that is there, the immediate part is, the immediate relief is provided. Now what happens is, countries which have not gone through the path or not done their homework can fail. And it's a very, I mean, from India it's a bad point. I don't know how many of you remember, there was an earthquake in Pakistan occupied Kashmir. Afghanistan and Pakistan occupied Kashmir, and a lot of people were displaced. Unfortunately, the state of Pakistan, the governments of Pakistan, whether the state government there or the central government there, could not provide speedy relief. The speedy relief was provided by organizations which are basically banned and terrorist organizations. And this led to terrorist recruitment and the funneling of terrorists into the country. So the earthquake there in Afghanistan and basically in Pakistan occupied Kashmir, was a triggering point for the inflow of terrorists into India, because the Pakistan state could not provide the relief. The first thing, these organizations which are the mother organizations of Lashkar-e-Taiba and Jaish-e-Mohammed, these were the first ones to go there and provide the relief, and they could persuade the youth and the youngsters to come and fight for them. So this is problem in some place and problem in another place, the infection in another place. Next comes the recovery. Now recovery, the set of institutions are again different. They have some time to raise the funds, and they again need the funds from the public financial management system. So that is there. So remember, initially, say the total money which you require, say, is 100 crores. The initial relief amount should maybe perhaps 10 to 15 crores. The remaining 30 crore, another 30 crores would be for recovery. And the remaining 50 odd or 55 odd crores would be for the reconstruction of primarily the civil and structural work. So relief, recovery, and reconstruction. The amount of money varies and the time scale varies. Okay, the amount of money varies, and the variation could be 1:5. That is the general 1:5, 1:10. That could be the general amount of money between relief and recovery. And it can go even further for reconstruction. And if relief is done correctly, the government gets enough time to arrange funds for recovery, and thereafter the reconstruction. I will get into the next slides how to arrange the funds, which of course is difficult given the fact that most of our governments all across the world are basically in running on debt. The next is how money reaches beneficiary is as important as where it comes from. Disbursement of funds, how money reaches beneficiaries is as important where it comes from. Okay, so you have basically public services, livelihood support, public assets, and a strategy by the government. Okay, the public services, police, judiciary if not there, police, block development officers, PWD fellows, the disasters relief forces. Okay, these are the initial public. They need to be financed. I know it's a bit difficult to understand, but you need money to even move them from place one to place two. Okay. Now, governments require dedicated mechanisms and expertise to allocate, disburse, and monitor recovery and reconstruction funds. Unfortunately, a lot of seepages and corruption has happened in our country and everywhere also in the reconstruction thing. And basically, you require a crucial, transparent, and accountable system for managing the public funds, which are basically required to reconstruct the public assets and for livelihood support. Now, you see, it's a basically four thing. The government must have a disaster relief, relief financial strategy, risk financial strategy to manage three things: public services, livelihood supports, and public assets. Now, public services, electricity, water, sewerage, primary health, that the first thing. Then livelihood support, earnings, the people need to go to their earnings. And then last, the public assets, and these are all three different entities. They all have different kind of accounting systems and ways of reaching money is different. So government needs to do this, or the system needs to have this in place. Next in this is, no single financial instrument can address all risk. The reason why no single financial instrument can address all risk is because every financial instrument has a certain cost attached to it. Okay, so if the government raises debt, say, let's assume that there's a disaster, unfortunate disaster, and the government has to raise a debt, say, of 1,000 crore rupees. They will issue debt to the publics, mostly to the banks. The banks will give a part of our savings to them as debt, and the government will raise debt at the rate of, say, 7% per annum. So 7% per annum would be 70 crores. Now what happens is, this 1,000 crore would be added to the sovereign debt. Okay, this 1,000 crore would be added to the sovereign debt. Our public debt to GDP ratio rises, and this puts a strain on the overall fiscal timetable and fiscal preparation which we have done, and it starts affecting. Okay, now 1,000 crore rupees has been taken away from the system. That means the general public of India, the companies, the firms in India are deprived of those 1,000 crores. So the interest rate starts increasing. When the interest rate starts increasing, things start becoming costlier for the rest of the countrymen. Whether it is you want to build a home, you want to buy a scooter, a car, or whatever, or the company wants to expand or want to do expand or recruit more people, the cost of money goes up because the government has already taken away 1,000 crore rupees, and the government can always change the these SLR CRR ratios. They always have it. They can always increase the ratio. So what happens is 1,000 crores, no government takes the loan. It's never less than 40,000 or 80,000 or 1 lakh crore rupees. So they divert that money from the public finance, and the money goes to the government. Now that much money is no longer available with the Indians and with the Indian firms. So whatever money is there, the interest rate rises. So say the government has borrowed at 7%, the general public, if they were paying, say, 12%, they would pay 13% or 14% for the extra money, extra loan which they have to take. Now when they take loan at extra higher rate, everything else becomes costly. So this is how the government starts getting affected. Apart from that, the public debt rises. So public debt in India would rise by 1 or 2 points. And what would happen? This has a ripple effect on the rate of rupee and dollar. So the dollar, which we all know is now appreciating, rupee is going down. And this is actually what happens. More debt by the government ends up putting pressure on the rupee or the rupee dollar, or in any country, whatever currency they are using. And it puts a pressure on the domestic currency. The domestic currency slides again, and then it's what we call a double whammy. The imports become cheaper. A country like India, some of the imports are fixed imports, we cannot change, like oil, gas, fertilizers, some electronic goods and capital goods. which we have to import from outside, and coal also. We import a lot of coal. So what happens is 40%, 25 to 40% of our imports are fixed. So we have to pay higher in terms of rupees. So this is how, it has a ripple effect. The government can raise the taxes. Yes, it can raise the taxes. Who's stopping it? But taxes, what happens is beyond a certain rate, things start going underground. If they raise the income tax, people will simply not declare their income. I'm not talking of the salaried people, they don't have a choice. But businesses and others, they will simply not report, or they will show some extra expenditures to hide their income. And what happens is a lot of these people, then they start under invoicing or over invoicing their export, import, and other bills. And a lot of money in such circumstances moves out. This personally I have seen. I just did an informal study. I have seen it happen in the case of Pakistan. Now you'll be surprised why somebody like me is so fascinated. They are our neighbors, nothing else. And when I was growing up, they had a better cricket team than ours. Imran Khan, Zair Abbas, Javed Miandad, they were better than ours. So my fascination is always there, if not my admiration, but my fascination is there. So what happens is whenever they had a disaster, and within few months or a year or after the disaster, they had this lot of this capital flight, dollars going away through black market, hawala to outside. And it happens in India also, believe me. I've seen it happen in 80s and 90s in India, especially in 80s in India. It would simply go out. There is something for which the government has to raise funds. They raise through debt, they raise through taxes, and the money starts going out. And the money starts going out. So, this is a normal third world, developing world activity. Any such natural disaster or unnatural disaster happens, the government raises money through either two sources, and fund diversion then starts taking place outside. Okay. I'm sure all of you are familiar with the term, at least hawala, the illegal transfer of foreign exchange out of the country. Okay, this is what happens. Anybody so far has a doubt or anything, please raise your hands and then ask me the question. Yes, Professor. There was some Jagannathan.
Yeah, good evening, sir.
K. Jagannathan.
Amitji.
Yes, sir. Yes, sir.
Very interesting lecture, sir. I got one question. You mentioned in your lecture that our debt to GDP ratio is 75% or so, whereas the so-called developed countries, most of the countries it is 150, 200, and so on and so forth. So how is the value of decreasing debt to dollar in that case?
Okay, I'm going out, but this must be a natural curiosity because rupee has gone down to 87 versus dollar, something like that, 84, 85. I will satisfy your curiosity, try to satisfy curiosity. What happens, sir? There is a component called export minus import in our GDP calculation. Okay. In the case of India, export, this component is negative. Okay. And this component is, filled up. It's a very large negative thing. And this component is filled up by remittances and capital flows and all that stuff. Now, when this component, India finds it difficult to fill up, then there is only one way to do it. That is to let the dollar slide high against rupee, or let the rupee slide, so that imports become costly and exports becomes cheaper. When exports become cheaper, foreigners would buy more products from India, whether it is IT or whether it is garments, and we will import less from China, Japan, South Korea. Okay, that is the thinking. Yes. That is why the rupee slides against the dollar. Okay, and it is primarily defined by this real effective exchange rate. Basically, forget the mathematics, trying to balance out the inflation difference between India and Pakistan. So for 2 years, Professor Rao, the Indian government did not allow the RBI to depreciate the rupee against dollars. Because of that, we have actually lost notionally $130 billion. Okay. Now, in normal circumstances, currencies slide so as to account for difference in inflation and account for difference in export and import. So that is why this is happening. For 2 years, India did not allow this. Now we are allowing to do it so that the imports become costly. We reduce our imports and our exports become cheaper and more competitive, and their countries start buying our exports. It's a yuan is depreciating, rupee is depreciating, and I expect other currencies to depreciate. Now there's one problem in this. in its in the case of a country like India, anywhere between, I'm not very sure, I've not checked it, anywhere between 25 to 40% of our imports are fixed. We cannot do anything, we have to import. Let's take oil and gas, we have to import. 85 to 90% of crude oil India has to import. I mean, we don't have that much crude oil. Similarly, almost 45-50% of natural gas we import. Okay, then we import a lot of these fertilizers, NPK. In fact, we import urea fertilizers, and we import almost the entire phosphate and potassium fertilizer. Okay, these are all imported. Similarly, we import lot of coal. I don't know whether you're aware of not, but India is a India though is one of the largest producer of coal. Coal India is the largest coal mining company in the world, but we have low grade coal, and we need that metallurgical coke or anthracite coal in our thermal power plant and in steel plants. Okay, we require the highest grade coal, which has the highest amount of carbon in it. So we import coal, we import gas, we import oil, we import jewelry to both consume as well as re-export. Okay, we import diamond, we import a lot of diamond to consume little bit and to export most of it. Okay, we import a lot of electronic products from China. So that is why our 40%, sometimes it is 25, sometimes 40, anywhere between 25 to 40% of our imports are fixed. Whatever may be the price of dollar, we as a country will have to import it. When I was a student, this was 70%. When I was a student, I used to check up through Economic Survey of India. This was 70%. So that is why we had a lot of deficiency in consumer products. There was hardly any dollar left to finance for picture tubes and all that stuff. I'm talking of the time when TVs had picture tubes and all that stuff. Okay, so that was the time. We did not have enough funds to go around for that, because 70% of our dollars, what we had, used to pay for oil, gas, fertilizers, and all that stuff. This is what happens. This is what happens.
Thank you.
So, Professor, I hope it's clear. Okay.
Yes, thank you so much.
Amitji, I have one question, sir.
Yeah, go ahead, sir.
Yeah, actually, to handle these disasters, so do the governments maintain any fund like disaster risk funds or something like bonds or something?
Sir, I will come to it a little later. The government does not have any such like that. They issue it later on. They issue it later on. But again, bonds mean the government is taking debt. Okay. And this debt has to be reported. Again, all accounting systems, public accounting, public finance accounting systems, the IMF has given a structure. All governments have to comply with it. The moment you don't comply with it, you are out. Okay. You are out, and the repercussions are quite heavy. So you have to comply with it. So the moment you issue a bond, that means you are taking a debt. The moment you are taking a debt, what did I tell you? You are taking away that much money away from the Indian corporates, Indian firms, and Indian individuals. So that there's a money shortage and the interest rates goes up. What happens? The government, then the public debt rises. Once the public debt goes beyond a certain level, the dollar and all that start depreciating. And what happens is, some smart or cunning individuals, they start doing that hawala kind of thing, over invoicing, under invoicing, and all that, and the money and the dollar starts flying away. So governments are always wary now. I believe the governments all over the world have learned, especially in the disaster days of 70s and 80s, that, and right up to the 90s, that doing this kind of thing would invite trouble down the line. Sometimes the trouble takes just 1 year to happen. Sometimes the trouble takes 5 years to happen. So bonds not always are a good way of raising money, because sooner or later it gets affected. Also, what happens is, if the State governments, and the same for state governments. If the state governments take issue bonds, okay, most of the state governments in India are gone cases. I'm sure you are aware. If you just read the newspapers, a lot of these state governments, I will not name the states because uh, I think, even Andhra Pradesh is not managed fiscally quite well. Andhra Pradesh, West Bengal, Maharashtra, Punjab, the Northeast, these are not managed well. No, they have a pretty high debt to GSDP ratio, gross state domestic product. Okay, and this Northeast states and some of these states, and closely followed by UP, Bihar, Rajasthan, MP, and other these states. There are very few states which have done reasonably good fiscal public finance management. So if the state government takes a debt, it also gets reflected. And if there is a certain level of beyond a certain level of debt for a developing country like India, what happens is we will stop getting money from World Bank. And let me tell you, we are the World Bank has given the largest amount of soft loans to India. We have I mean, 2 years back, our international debt was $500 billion. Please don't be under the mistaken assumption that we don't take debt. We take a lot of debt, but we take it from these big multilateral bodies like Asian Development Bank, World Bank. We take it from them, not IMF, but World Bank, Asian Development Bank, then overseas development assistance program of Japan, all these. So we take soft loans from these, okay, to build the infrastructure. So, Dr. Sundar, this satisfies. We normally, it's not a very safe route.
Yeah,
No,
yeah.
it does not.
Not bonds. Are there any other instruments like some products like for DRF products are there? Like
I'll come to. I can
sure.
propose, sort of propose.
Yes,
Okay,
sir.
I'll do it. Okay. So now coming back to it, coming back to this. Then no single financial instrument, that's what I was saying, disaster risk layering. Now what happens is you have basically three sorts of funds. One is budgetary instruments, the other is the contingency financing, and the other is the market based instruments. Basically the budgetary financing, you have to budget for it. Budget means you have to show from where you have earned it and where you have obtained the funds. Now what happens in the case of, say, country like India, I'll just give you, see our, if you just see the general from where the rupee is coming. I mean, last year I checked, last year I went through it in a bit detail. 36% of our fund is going towards meeting these subsidies, okay, agriculture subsidies, food subsidies, and 33% of the funds which the central government is raising is through debt instruments. So budget, if you make it, if one third of the source of funds is debt, that is not exactly good. That is not what we call in finance a prudent way of managing the funds. Though one advantage the government has, the government is the sovereign, the government can fix the interest rate. Now this is where Professor Sundar Kumar, the governments play the mischief. They reduce the interest rates. They reduce the interest rates. Okay, so a government today, if it wants to raise funds, it can reduce the interest rates to 5%, 4%, and that is what the developed world has done. They have reduced the interest rates to the interest rates by I mean the rate at which the banks give the money to the government. They have reduced the rates of interest to 1%, 2%. In fact, in Japan, it had gone down to even 0.1%. Okay, so governments have one advantage, they can reduce the interest rates. Number two, in public finance, the governments can simply sit coolly by simply paying back only the interest. They can simply ignore the principal. They will simply renew the loan. That is what they do. They simply renew the loan. That is one big advantage a government has. So that is how they meet their budget. That is, they finance it through debt. Okay, debt per se is not bad, but debt is, from government point of view, debt per se is not bad because they simply have to meet the interest payments. The only thing about the debt, and especially public debt, is that if it is, what happened? Can you hear me, sir?
I'm listening, sir. Go ahead,
Okay.
sir.
What happens is what happens is that how much of the debt is held by foreigners. Now that becomes difficult. So if in the case of India, very little, only 20% of our debt is 15 to 20% of the debt, around about 20, anywhere between 15 to 23. Only 15 to 20% of the debt is held by the foreign bodies. The remaining 55% majority is held by us. And even if it's a foreign body, it's like World Bank or Asian Development Bank and all that. So that's not very big. And if the debt is held by the foreigners, that is what has happened in the case of Latin American countries, it can be extraordinarily disastrous. Even in the case of our neighbor Pakistan, it's also quite disastrous because 50% of their GDP, basically, the foreign debt is almost 50 to 60% of the GDP. In the case of India, it is 15 to 20%. In the case of Pakistan, it is 50 to 60%. Now, remember, if it is 50 to 60%, the repayment, both in terms of interest and the principal, is in dollars. Okay, so that becomes difficult. They don't export that much. They don't earn in remittances. They have to. In the case of India, we earn enough through remittances and exports and foreign direct investments and all that stuff to pay back the interest and the principal. That is one advantage we have.
Okay.
So now you get it. The debt, if it is held by the foreigners, that becomes very difficult. Now you'll be very surprised if you just see the debt held by the Japanese. It's a very huge, it's humongous. I believe it's 200% or something like that, public debt to GDP ratio. But most of it is held by the Japanese. In fact, there was a story that most of the debt was held by the Japanese women. They had given money to the government of Japan through the banks. Okay, so if it is domestic, you can always decrease the interest rate amount. Then that's what the Japanese did, 0.1%. That's practically free. 0.1% is practically free. So coming back to this, you have the budgetary instruments. Budgetary instruments are primarily taxes and debt. Contingent financing means anything which has been saved for such disasters, which normally they don't, and that any such savings or any such account maintained, which the governments do, which normally they don't, and from that they provide the initial funds. Then the next is market-based instruments. Market-based instruments are, I'll come to it a little, is basically like your property insurance, agriculture insurance, or any insurance instrument. Okay, these are market-based instruments, and they have their own limitations and advantages. The limitation is, like all insurance I have just discussed, the insurance is passed on, it is collected, and it is collected, aggregated at the level of reinsurance, and it is passed out, and you never know who is holding what instrument, who ends up holding what is called as collateral debt obligation or collateral to the debt, who ends up holding it. And insurance needs some sweetening offer in the form of tax rebate. That is one disadvantage. Unfortunately, for reasons which I still don't know, I have not been able to comprehend, agricultural insurance in India, or especially one part of it, the crop insurance has not been a successful instrument in India. I don't have answers for that. Disaster strikes, suppose there is a sudden flood goes out for some reason which I don't know. Crop insurance, because I was associated with insurance firms as a part of my teaching, and crop insurance somehow did not pick up. The companies were also not very keen, and the government was very keen, but somehow for some reasons crop insurance did not take up in India. Okay. I'll come to the insurance a little later. Okay. Now, okay. So this is now the last is the question of, to make sound financial decisions, the governments need the right information, and for that basically you have data analytics and all that stuff. Okay, data analytics everybody now knows. I mean, I need not say, there are people who understand it better than that. The government needs a lot of data to basically, here data again is related to the actuarial insurance data. Their data is kind of, so they do a lot of data. They have been doing data analytics for a very long time. So it's related to the insurance thing, the actuarial data, and that data is required. Now, can you just go back to slide number 4, sir? For the public, slide number 4. No, pre-disaster. Pre-disaster. Insurance, pre-disaster financing. So in the first part of my lecture, I had initiated that disaster, two types, pre-disaster and post-disaster. Pre-disaster is primarily insurance. The insurance carrier promises to indemnify, that is to make up the potential losses. Indemnify here means make up. And there are two kinds of insurance products. One is the indemnity insurance and the other is the parametric insurance. Indemnity insurance, that is the exemption from liability for damage. So we all have a motor vehicle insurance. So if some damage happens, the damage is, at least theoretically, practically I know, I had to do it. One student had scratched my entire car. One student, I had asked him not to enter into my class because he was coming 15 minutes late in a 1-hour lecture. I asked him not to. So he had scratched the entire. And when I went to the insurance firm, I found it is cheaper to do it from myself. But anyway, theoretically, the insurance firm says that we will meet up the damage. We are liable for the damage. We'll meet it up. This is a standard insurance policy. Now, and how it is met? Well, I've given an example. An overbridge is insured against an earthquake. The insurance firm takes into account data from geology, seismic data, civil and structural engineering data, and juxtaposes the same with the financial aspects. That is the depreciated rate of the bridge, the remaining life of the bridge, etc., replacement rate, and gives out a figure for the insured value and the premium. So that is one thing. Okay. So the municipality or whosoever owns the bridge, the state government, whosoever, keeps on paying certain, the premium. Okay.
Sir, what about that parametric insurance, sir?
I'm just coming. This is the most interesting part. Yeah. Come down to the next slide, please. Parametric, I know. Parametric, we all think parametric is parametric and non-parametric distribution. A parametric distribution is structured slightly differently. Actually, you all should be surprised, but I find that the insurance industry is one of the most innovative. They have to think out ways of products, and they think out ways of creating insurance for it and all that stuff. One such wonderful thing is a parametric insurance policy. Now, it is basically, there is an event which must happen, and that is what we call a triggering event. So let's take the same overbridge thing which I was taking. Overbridge is built for protection against earthquake. Now, a parametric insurance policy would be triggered, that is activated, if say there is an earthquake of say over 7 on Richter scale in daylight, say during working hours when a lot of people are moving on the bridge, and there is a earthquake of 7 and above, then that parametric insurance policy is triggered. And there is no direct relationship between the occurrence of disaster and loss of an asset. There, the most important part is that there must be a trigger event. So in this case, the trigger event is the 7 and above on Richter scale in daylight. Is that clear? This is the parameter which are variable. Parameter is the variable which has fit into the equation. If this is
below 7, they won't.
No. The parametric insurance won't be triggered. Okay. Yes, below 7, it won't be triggered. Okay, if there is a 6.8 and damage happens, sorry, the parametric insurance policy won't be triggered. The parametric insurance policy will be triggered if it is 7 and above. Then the insurance firm would pay. And what happens is, like all sensible people, governments are made up of sensible people. It's just that they sometimes don't act. You can take a hybrid, that is a mixture of indemnity insurance, that is the standard insurance, and your parametric insurance.
Parametric insurance is cheaper than indemnity insurance?
No, normally, sir, parametric insurance, yes, it's cheaper. It is cheaper. And you'll be very surprised to know why it is cheaper. It is cheaper because very little labor is spent on calculating the parametric insurance.
Okay.
The labor which goes into calculating the parametric insurance, the time and the efforts is much less. So that is one reason why parametric insurance is cheaper. And one more thing, the company which is doing the insurance most likely is not going to hold it. It is going to pass it on to some reinsurance firm. But parametric insurance per se, that is standalone parametric insurance is generally cheaper than your indemnity insurance. Okay, but there has to be a triggering point, and that of course varies. So a lot of these people, especially in Japan and others where earthquakes happen, they have what we call as a hybrid insurance, a mixture of parametric and indemnity insurance. Okay, so that is how they manage the things. Next slide, please. Post disaster.
Ganesh Garu, next slide.
Post disaster. One, I have discussed borrowings. One is budgetary reserves, which unfortunately does not exist. The other is emergency funds, which the last two need to be created. Now, Professor Sundar Kumar, you are asking what sorts of financing. Well, one way of financing is that to create a sinking fund through issuance of surcharge and cess. We pay cess and surcharge on petrol. We pay cess and surcharge on income tax. Okay, we all know where it goes. It goes to fund the roads and all that stuff. So we basically, what happens is, the idea is that a sinking fund means a separate fund is created and it gets a regular. So we can have a surcharge of say 50 paisa on every liter of petrol. Okay, Odisha government can issue a disaster surcharge of 50 paisa on every liter of petrol and 50 paisa on every liter of diesel. Now, when that happens, for every liter sold, 50 paisa gets collected at the state government's end and a corpus is built. And from that end, they can keep on. And what happens is that sinking fund is, that fund is also invested somewhere. Governments can also invest that fund, and they do it. Governments invest fund in some sound corporate treasury borrowings, or some they can give loans or whatever. So the governments then can do another financial management angle to it. That is, they can invest the money in some other activity from where they can get a fairly assured return. So the governments can loan money to corporates. Odisha government can loan money to say Tata Motors. Now Tata Motors is a very stable company. It's not going to run away. It's not going to go bust. And they can then, whenever they want the principal, they can always pay back. So this is how, ideally speaking, and yeah, cess or surcharge can be levied on something which is used by the masses, and it should not be exorbitant. So the basic thing is create a sinking fund which can be used later on. The sinking fund starts getting bigger and all that, slowly, and that can be used. And it's prudent financial management practice says that the moment you have a sinking fund, you go and invest it. Now, the governments have two ways of doing it, and actually I don't know much about the Indian governments. The foreign government organizations, they do a better job of avoiding doing it. What they do is they give the money to some financial institutions. Say they can give it to JP Morgan, and then JP Morgan can invest in some safe instruments, safe companies. Like JP Morgan can then further invest in Microsoft, Amazon, give them money, or say Texaco, Chevron, these big oil companies. And then whenever the money is required, they can simply take it out and give it back with some interest. So that is one reasonably safe. A cess or surcharge, other than that, within the current context, raising taxes, cess and surcharge is also like a tax, but a very small amount. Raising the income tax, whether corporate or personal, raising the GST, it's not going to work. Okay, it's not going to work. Now the next slide is delivery channels. This is yes. Remember that portion which I gave, relief, recovery, and the initial things which I was saying. the homeowners and all. This is more towards that. How to give them the money. So one scheme which is there, which I hope we don't get the chance to use that. Nobody wants a disaster, but which I'm sure the governments will use is smart governments, smart, especially the state governments. And by smart state governments, I mean the five South Indian ones and the this our Odisha also. I don't know Odisha now how smart it is, but Odisha one also is smart in terms of disaster. So I expect at least 6 and 7 state governments to be smart enough. Financial inclusion channels. Now, financial inclusion is a very big activity. In the last 20 years, India has done a lot. We were majority of our population was financially excluded. Financial inclusion means, in very simple terms, the World Bank and IMF and they all have defined it is getting maximum, basically how much, what is the percentage of people who are associated directly or indirectly with the banks. Okay, having a banking account, operating the banking account, and this is a multi-layered, having a credit card, operating the credit card, having a debit card, operating a debit card. So these are the financial inclusion channels. And now in India, the UPI, phone pay, Paytm, all that brings us the financial channels. So delivery channels are very important. You see, if the population is not connected to the is not financially inclusive, okay, so what happens is, then you cannot go and meet them, and then lot of hocus pocus activities takes place. The government officials will write, payment has been made, and payment will not be made. So if the financial inclusion, basically having a banking access directly or indirectly, that is the safest route through which this, you can say, the weaker sections can be met through. Okay, financial inclusion therefore is a prerequisite for any post disaster delivery mechanism. Indian government has been doing it since the last 20 years, and how do I know? Because a lot of research papers have been written in financial inclusion. A lot of financial inclusion activities have happened, and we have also taken the inspiration from some of the smaller countries. So we have also started going it in a big way. And of course, one of the biggest disruptors in the positive sense has been this UPI thing. So the moment they are connected, they can be given the money. Previously, this was the problem in 80s and 90s and in 70s also. They were not connected. How to give them the money, through cash or through kind or whatever. That was the one thing which was done, and lot of leakages happened in the disaster relief. Now if their financial inclusion is there, then it can happen. The other is the existing social schemes. Some of these direct benefit transfer and all these stuff, through whatever the mechanism for that, the PM Jan Dhan Yojana and all that, they can be used. So these are the two existing things which came to my mind to act as the delivery channel. Ladies and gentlemen, I am ready for questions.
Yeah, thank you very much, sir. I have a few questions, sir. You told previously about that parametric insurance. Who will opt that, sir? Because people does, even myself also, first I came to know from your lecture only about that parametric insurance, because our apartment is insured for natural perils like earthquake, fire, etc., etc. But in that, I never find this terminology
Sir,
parametric.
sir. India is not what we call a sophisticated country in terms of insurance products. Let's be very clear. The insurance industry, forget whatever you and I know from our that generation thing. Insurance industry in India is, you can say, the baby started becoming a baby. The conception of Indian industry started happening in 1999. Prior to that, we were whatever was there is not worth talking. Okay, so we are barely 25 years old. Okay, we are barely 25 years old. We need to have a lot of sophistication in the product. Okay, we don't have that. We simply don't have that kind of products and all that stuff. You go to these Caribbean countries, you go to these smaller South American countries, they all have these because disasters happened. And since these countries were connected, especially Latin America was connected to USA, so they had a lot of these insurance products. We don't have that. Dr.
Okay.
Sundar, this satisfies me because our insurance industry is barely 25. 1999, that Malhotra report came. Malhotra Commission report came to privatize the insurance and all that stuff. And then we actually started. And for every product, they have to take, every new product, they have to take the approval of IRDA, Insurance Regulatory and Development Authority. So they have to take it up. But I'm sure sooner or later, it will come. Insurance in India is just 25 years old. It's not it's not 100 years or 200. No. It is just 25 years old. Okay, sure. Go ahead.
Yes, sir. I recollect that terminology wording that I have read when I took that policy even 15 years back from my apartment. Anyway, good, sir. And what about another question, sir? Is there any difference between traditional insurance? Because insurance is the only financing way for solving the problems of pre-disaster. Traditional insurance and disaster risk financing, any difference, sir?
No, insurance is a part of disaster risk financing. Okay. It is a part of, it's a way of mitigating the disaster. But there can be other. If the government is brave enough, it can always go for raising debt. It can always go for raising debt. It's not that they have not done it. They can always go and raise debt. But debt, I have told you, all governments are buried in debts, and raising further debts can lead to chaos. What I've told you, the kind of chaos it can create.
Yes, sir.
Okay. Basically, even if the government raises debt, forget the government using it. Say it is 10,000 crores. 10,000 crores has gone out of the banking channel. Okay. Now that means the Indian as individuals, we cannot take loan from that much money is deprived, and Indian firms are deprived. Okay, of that 10,000 crores. And government does not borrow 10,000 crores. Government borrows 1,50,000, 40,000, 80,000. So that much money straight away goes out of the system. So insurance and creating a sinking fund through cess or surcharge or something, these two are the only safe viable options. Debt per se, I'm afraid, is not a very viable option. I mean, debt, it doesn't work out. It's never going to work out.
Right, sir. Very good, sir. Very enlightening lecture, sir. I personally myself learned so many things from you, sir. We will be definitely be in touch with you, and will seek knowledge from you through lectures.
Thank you. It's my pleasure. My pleasure. I'm a teacher. It's just a 90-minute class.
Yeah,
okay. Thank you and good night.
Yeah. Thank you, sir. Thank you very much, sir.
Thank you. Good night.
Yeah. Bhavani, ma'am, please propose vote of thanks.
Okay, sir. So thank you, sir, for your valuable session. So it is my privilege to deliver the vote of thanks for this insightful FDP on disaster risk financing. On behalf of Ramchandra College of Engineering, I extend my heartfelt Dr. Amit Banerjee, sir, for sharing valuable insight and expertise on disaster risk financing. Your thought-provoking session is truly enlightening. Thank you once again for your sharing your knowledge and expertise with us. We look forward to future opportunities to learn from you. Thank you, sir.
Yeah, thank you very much. Veerattam, sir, any concluding remarks? Thank you very much, sir. Good night, sir.
Thank you, sir. Thank you so much.
So all the participants,
Thank you,
Veerattam,
sir.
sir, please put the feedback in the channel, chat box, as well as the WhatsApp group. And all the participants, good night, and see you in the tomorrow session. Thank you.
Thank you.